Hi class, here is our last video, our last figure for the semester. A little bittersweet here. So we're going to take a look at the process through which lightning is created. And it all starts with separation of charges. And so due to updrafts, once again back to updrafts, the updrafts in a cumulonimbus thunderstorm cloud will separate the charges within the cloud so that positive charges collect at the top of the cloud, negative charges in the bottom half of the cloud, and positive charges will collect at the surface. I forgot to put those in. So here we go. All right, so after we get the separation of charges, then what happens is the negative charges, the negative ions in the bottom half of the cloud, will start to surge towards the surface, and we call this a leader. And a leader is a narrow channel of negatively charged ions. And okay, so the leader, a narrow channel of negatively charged ions, surges down towards the surface. This is not a lightning bolt yet. This is just negatively charged ions surging down towards the surface. Sometimes it'll be a single stream of ions, and so a lightning bolt will appear as simply one lightning bolt from cloud base to the surface, and sometimes it'll break off or branch off, and so we call those stepped leaders. So if it branches off, sometimes you'll hear some people call them branched leaders. And so sometimes you get some stepped leaders. And so when that occurs, we get branching in our lightning bolt. Okay? So as the leaders, the negatively charged ions, stream down towards or surge down towards the surface, when they get close to the surface, it encounters the positive charges. Okay? And so those positive charges, as the negative ions get closer, the positive charges are going to be pulled up. We call those streamers. And so streamers are the positive charges that are pulled up as the negative charges from the leaders approach the surface. Okay, so we've got, and typically these streamers will leave the higher objects, the taller objects in the area. So this is why you don't want to be the tallest object in a particular area, because a streamer could literally be leaving your head. If you're fishing, it could be leaving the fishing pole. If you're golfing, it might leave the golf club. So you do not want to be the tallest object in a particular area. So these streamers get pulled up by the negative charges of the leader. And I also use the example as a kid, maybe you did this too. I used to play with magnets, and you put a magnet on the table and you take another magnet and you see how close you can get to the other magnet before the one on the table gets pulled up by the one you're holding in your hand. So the magnet on the table is kind of like the streamers, the positive charges on the ground. The magnet you're holding in your hand is kind of like a leader, okay? And so as you take that magnet and bring it down towards the surface, it acts kind of like the negative charges of the leader, okay? When you get this connection between the two, when the negative charges of the leader connect with the positive charges of the streamers, then you get this connection taking place, okay? And this is called a return stroke. So a return stroke occurs when the negatively charged leader and the positive charge streamer connect. Okay, now when that happens, this is when you close the circuit of the lightning bolt, and you start to drain the electrons, and this causes the initial flash. Okay, and so you get a flash, and let me make that connection too. So this is the return stroke is the initial flash of the lightning bolt. Okay, and you start to drain these electrons from the different portions of the cloud. Okay. And the draining of those electrons from this channel is called the return stroke. Okay, and all right, so there we go with the return stroke. All right, no, I don't know what I was going to say. So the some people will ask, is it cloud to ground lightning or ground to cloud lightning? And the answer is yes, it's both. The ions, the negative charges, will flow from the negative charges will flow from the cloud to the ground, but the flash actually occurs from the ground up. Okay, so the drainage of electrons, of negative charged particles, is from the cloud to the ground, but the flash actually occurs from the ground up to the cloud. Okay, so the answer to that is both. All right, there's one more portion to lightning, and that is called a dart leader. So we'll put that over here. Number 4 is a dart leader, and this one's kind of cool. Dart leader, what it does is it drains negative charges from the cloud. And so what happens is maybe you're taking electrons from over here, okay, and this will flow down. So that's a dart leader, okay, and maybe you've got negative charges from this portion of the cloud, and that's draining down. And when these dart leaders occur and you're draining electrons from different portions of the cloud, they follow the exact same path as the initial lightning bolt. So maybe we got some more electrons here, and they're draining down the same. And every time it drains down this path, the lightning bolt is going to flicker. So if you ever noticed flickering occurring with a lightning bolt, those are dart leaders. Okay, those are dart leaders that are draining electrons from different portions of the cloud down the exact same path, and every time it takes that path, the lightning bolt is going to flicker. And so I always thought that was kind of cool. Now sometimes we don't see flickering and we think that there's no dart leader taking place, but our eyes are really slow, and sometimes you only see one flash, and that's simply because our eyes are too slow to see the flickering that is taking place. I mean, sometimes it's very easy to see, other times it's like, well, that was just a single flash lightning bolt. Well, it's probably because our eyes are just too slow. All right, so that is lightning, and again, it's really cool. It's one of my favorite phenomenons in meteorology is watching lightning. So anyway, that is it. That's our last figure for this year, and like I said, I hope you enjoyed the class. And your final is on Monday, so good luck.